Algebra 1 students, welcome to your 5.8 notes. This is the end of Chapter 5. We finish off with a great section on graphing and translating absolute value functions. I think it's a pretty straightforward concept. Stick with me, pay attention to the patterns you see here, and you will have a great time doing this assignment because you'll understand it, which is always nice. All right. An absolute value function is a V-shaped graph that opens either up or down. We've talked earlier about how you evaluate absolute values. We haven't graphed them before, but the graphs look like this. Essentially, they turn around because once you hit negative values, you start to just change them to positives, and so it just bounces right back up. Whereas if you took negative absolute value of x, you could see that graph is actually the V shape facing downward. It's always negative. I should point out that we call that little maneuver right there from here to here a reflection. So we're getting a little preview of transformations. We're going to stick with basic transformations today, translations to be specific, which are when we move a graph either vertically or horizontally. The translations of different absolute value functions are demonstrated below. Basically, I just used the number 3 everywhere, and so I wanted to show you what they look like. The absolute value of x is the blue function that you see on all 4 of these graphs. You'll notice that inside the grouping, when we do plus 3, that actually shifts the graph to the left. Whereas when we do minus 3 inside the grouping, the graph moves to the right. When you do a plus or minus 3 after the grouping, outside the absolute value bars, like you see here, y equals the absolute value of x plus 3, that moves the graph up, where absolute value of x minus 3 shifts the graph down. On these next several problems, next 4 to be precise, we've actually got transformations already done. We're going to work backwards and actually write the function. So here we go. We know that the absolute value function is f of x equals absolute value of x. That's our blue function that we have on all 3 of these. Now the 4th one is a little different scenario, but let's talk about the new function. In this case, that function is black, and I suppose in all 3 of these cases. I'm going to call that function g of x, and here's what we have going on. This graph is moving up exactly 2 spaces. To move up, if you might want to look back at that last slide, but that basically means you do plus 2 outside of the grouping or outside the absolute value bars. On number 2, this time our graph is moving to the right, and it's moving right by 5 spaces. So what we would say is g of x is equal to, now remember when you move left and right, the movements are actually inside the grouping, and we would call this, and this may surprise you a little bit, but x minus 5. So that's the absolute value of x minus 5. A minus 5 means you move right 5. Keep that information in mind. I want you to do number 3 on your own. Like a lot of the problems you'll see today, they're pretty quick. It's a question of are you going to get it right or wrong. I'm hoping for right, but you'll have to make that decision. All right, so this graph, we could see that it moved exactly 1 space to the left. So we know that plus 1 inside the grouping would actually move us left. We'll talk in just a moment about that whole, why does plus move us left where minus moves us right? That could seem a little confusing perhaps. All right, now number 4, we don't have a graph, we just have words. The absolute value graph is shifted down 17 units. So if it's going down 17 units, I know that the vertical changes are always outside the grouping, and it just makes sense. Down 17 means minus 17, and that is number 4. All right, let's take a moment. I created a little diagram I want to look at on Desmos, and you guys know how to use Desmos. You could do this on your own as well. I just typed in y equals the absolute value of x plus h, and by the way, that absolute value function is if you just go to the keyboard for Desmos, it's this one that I'm pointing to right here. It's an A inside absolute value bars, and you could type it in just like this. Now what I want you to watch is what happens is h moves. That's inside the grouping, right? So we know that's a horizontal movement. As h moves to the right, I'm making h closer to 10. I'm moving to the right. Take a look at the graph though. That's shifting left. And then as I move back left, as I make the h value smaller, and now it's negative, and all of a sudden my graph's moving to the right. Okay, so you can see when we have a negative value, it actually moves us right. Positive value moves us left. Seems a little backwards, okay? There are some reasons for that. The way I think of it is inside the parentheses, wherever that is equal to 0, that's where my graph is going to change direction. That's where the vertex is going to happen, because that's when the absolute value starts to matter. The absolute value of a positive number is useless. It's just what it is. But the absolute value of a negative, that's when things start to change. I'll go ahead and show you this, although I think you know it. The k value, if you move it larger, it moves up. It's coming back now. Make k smaller, and it moves down. All right, so let's get back to the notes and take a look. We're going to do some graphing, and we're going to start by considering the parent function, y equals the absolute value of x. So what I'm going to do is actually go ahead and sketch that. Essentially, absolute value of x is just the line y equals x. It has a slope of 1, y-intercept is 0, until you hit the origin, and then it changes to have a slope of -1. So it looks like this. That's your v. All right, so let's do number 5. Y equals the absolute value of x minus 3. The thing we have to keep in mind is, what is that minus 3 doing? Well, that is shifting down 3 spaces. So I'm going to go ahead and do a new graph here. I'm going to move down 3 spaces, but it's the same graph, just shifted down. So there's number 5. There, I got it. That's number 5. This is almost too easy, isn't it? All right, let's take a look at this one. Y equals the absolute value of x plus 7. We have to think about transformation. That one's inside the grouping, so it's kind of backwards thinking here. This is plus 7, which means we're actually going to go left 7 units. So again, I'm going to graph that same function, but I'm going to start all the way over here at -7, and it would go like that, since the slope is -1 that way, and then over here the slope would be +1. So my graph should look something like that. All right, why don't you do this? Try number 7 on your own. Let's see if you're getting the idea. So pause the video, do number 7, and then compare your answer to mine. All right, and welcome back. Here is my work on number 7. It's basically just a shift to the right 3 spaces. You'll notice that part of this graph ended up overlapping with the graph I had from number 5. That's okay. It's not the same graph. As you can see, the red and the purple only overlap for a piece of the graph, not the full thing. But in any case, there are the 3. Folks, I hope this fairly brief lesson is one that makes sense to you. If you have questions, make sure you come to class ready to ask them, but most importantly, get ready to work. You guys have a spectacular day.